So this time averages, whatever we have discussed for a random process, is not equal to ensemble average. It will not be same as ensemble averages. Okay. So we have to discuss when this will be same as ensemble average. Okay. Now for a random process, for example, we are getting the sample functions x of t, y of t plus tau, or this we have discussed, no? X of t plus tau, or this or the sample function we are getting from the random process. Okay. Now if you find the time average of all the sample function, we are finding time averages, no? If you find the time average of this sample function, will give us random variables. It will give us random variables. Okay. So the expected value of, that is ensemble averages of this random variables. Okay, that is expected value of this random variables will give us ensemble averages. Okay. So we have discussed that when you have random variables, okay, that is the expected value of this random variable will give us ensemble averages or no. So similarly, when you get random variables here, we get random variables when you find out the time average of sample functions. Okay, when you find out time average of sample function, it gives us what? Random variables. Since we have random variables, if you find out the expected value of statistical properties, expected value of this time averages gives us ensemble averages. Okay, ensemble average. So, what is that we have discussed here? We have discussed that how do you represent time average? A, capital A we use to represent time average. So, capital A of x of t gives us the time average of the sample function x of t. So, if you find out expected value, so expected value of A of x of t is equal to what? Expected value of, what is A of x of t is small x bar. Okay, so that will be equal to what? That is equal to the ensemble average. How do you denote? Expected value of capital X of t is the ensemble average. So, so it is equal to x bar. So it is equal to what? Expected value of x bar is equal to x bar. Okay. So then we also know that the expected value of time average of the product x of t plus tau. What is this function? Time average of the product x of t plus tau is nothing but time autocorrelation function. Okay. So how do you write? It is expected value of time autocorrelation function. How do we denote? With a capital R with a line here, two lines you have to use here. Okay. So Rx of tau. Okay. So it is equal to what? It is equal to ensemble autocorrelation function or statistical autocorrelation function. What is statistical autocorrelation function? Rx of tau. Okay. So I have to see the difference of representation of time autocorrelation function and statistical or ensemble autocorrelation function. Okay. The third one is the expected value of time average of x of t, y of t plus tau is equal to expected value of, how do we denote? Time auto cross correlation function here, Rxy of tau is equal to Rxy of tau. This is ensemble autocorrelation function. Okay. So from this we have discussed that if you find out the time average of sample function, it gives us random variables. So expected value of random variables will give us what? Ensemble averages. So from that we know that how do you find out time average? To denote time average we use capital A. Okay, expected value of capital A of x of t is equal to a of x of t, how do we denote it as small x bar? Okay, expected value of x bar is equal to expected value of capital X of t. What is capital X of t? Is ensemble average of samples, random process. Okay. So from this, expected value of x bar is equal to x bar, and similarly expected value of time average of the product x of t plus tau is nothing but time time autocorrelation function. Expected value of time autocorrelation function will be equal to ensemble autocorrelation function or statistical autocorrelation function. Okay. Similarly, this expected value of time cross correlation function will be equal to ensemble cross correlation function or statistical cross correlation function. Okay. So this is the first case 1. Okay. So in the case 2, we'll be discussing that if the time averages are constant, okay. If time averages are constant, means what? This x bar, small x bar, is equal to constant value. Okay. Similarly, that Rxx, how do you denote time average here? So the name time average can be used for all this one. X bar time C. Time average is the name given to time average function, time autocorrelation function, time cross correlation function. All these functions together we can call it as time averages. Okay. So Rxx of tau is also time average. Okay, but it is time autocorrelation function. Say if it is equal to constant, like these are constants. Okay. Similarly, R C you have to denote this like this. 2 lines we have to use for time averages. Okay, if it is also equal to constant. That is time cross correlation is also constant. Then can you tell me what is this expected value of x bar? Since x bar is constant, what is this value is equal to x bar only. So from this we have to discuss that expected value of time averages gives us ensemble averages. Okay. So expected value of x bar is small x bar only, that is equal to capital X bar. So it means that time average is equal to ensemble average. Similarly, time autocorrelation function. Time autocorrelation function is equal to what? The time autocorrelation function will be equal to ensemble correlation function. It is ensemble correlation function. Similarly, expected value of R xy of tau, because what is R xy of tau is constant, because all time averages are constant. So expected value of a constant will be equal to constant only. The same constant will be a lesser known from the properties of expectation. So just now here in the previous case, expected value of time averages are equal to ensemble averages. So that is why it is equal to statistical cross correlation function. Okay, these are the two cases we have for time averages.